Good morning, dear students. So in today's lecture, we are going to start the linked list. So, the basic things that we are going to cover in this lecture includes to identify the features of linked lists and defining a linked list. So dear students, today we will have a brief introduction on how a linked list works, and later on in subsequent videos we will learn to implement the linked list and its various operations. So here let's start with the session. Dear students, let us take an example. Suppose you have to write an algorithm to generate and store all the prime numbers between 1 and any given number. Let's say here we are taking an arbitrarily large size number. Now how will you solve this problem? We have a solution for this. Let us look at the solution. So we have an algorithm which starts by setting a variable I to 0, and then in the next step it is saying repeat step 3 varying n from 2 to the given number. So we are starting the loop from 2 because the first prime number is 2. The next step checks if n is a prime number, then set ith index of array A to the given number or to the number which has been scanned to check for prime. After that, the loop increases for subsequent elements. Next, repeat step number 5 varying another variable j from 0 to I minus 1, and then display jth index of the given array. So this two steps, that is step number 4 and step number 5, is fetching values from the given array where we have stored the prime numbers. Now there is a problem in this algorithm. So what is the problem? The number of prime numbers between 1 and 10 lakh is not known. So we had taken 10 lakh as the upper bound. So how many prime numbers do we have within 1 to 10 lakh is not known. Since you are using an array to store the prime numbers, you need to declare an array of arbitrarily large size to store the prime numbers. What would be the disadvantage of this approach? The first one, if the number of prime numbers between 1 and 10 lakh is more than n, then all the prime numbers cannot be stored. Similarly, if the number of prime numbers is much lesser than n, then a lot of memory space will be wasted. Thus, you cannot store an array, you cannot use an array to store a set of elements if you do not know the total number of elements before working or before using the array. So how would you solve this problem? By having some way in which you can allocate memory as and when it is required. So this process of declaring or allocating memory as and where required is known as dynamic memory allocation. Now when you declare an array, a contiguous block of memory is allocated. So have a look at the declaration of an array. Here we have declared an array of size 10 to store the first 10 prime numbers. one contiguous block of memory for each of the given prime numbers. Now here you can see the starting address or the base address of the array is allocated with 1000 memory allocation, and subsequently memory is allocated for all the elements. Here, if you know the address of the first element in the array, you can calculate the address of any of the elements given in the array. How can you calculate this? So you can calculate this by using the formula the address of first element plus size of the element into the index of given element. So the first element gives you the base address. In this case, it is 1000. Now when the memory is allocated dynamically, a block of memory is assigned arbitrarily from any location in the memory. Means during the allocation of memory, the memory block which is found first vacant is allocated to the element. And therefore, unlike arrays, these blocks may not be contiguous and may be spread randomly in the memory. So in this case, we cannot calculate the address of the given elements or the stored elements. Let us see how does it happens by allocating the memory dynamically. So here, this one we have the memory area. So the first prime number, which is 2, we have allocated memory 1002 for the prime number 2. Similarly, for next prime number 3, we have allocated 1036. For 5, it is 1008. For 7, it is 1020. Similarly, we can allocate random memory locations for the elements to be stored. Now, if you know the address of the first element, you cannot calculate the address of rest of the elements. Here in case of the address, the first element is 2, whose address is 1002. So by knowing this address 1002, we cannot calculate the address of the subsequent elements because we do not have any chronology, any sequence to store the elements. So to access any element, you need to know its address first. So this is also a problem. Now how will you solve this problem? So therefore, it would be good if every allocated block of memory contains the address of next block in the sequence. Like, so we had the first element 2, which is storing the address of its subsequent, that is the next element, whose address is 1036, and 1036 is the address of our next prime number 3. Similarly, the second prime number, that is 3, stores the address of the third prime number 5, that is 1008. This is 1008 for 5. So we can illustrate this in the form of a link also. Here 2 is storing address of 3, 3 is storing address of 5, 5 is storing address of 7, and 7 is storing the address of 11. In this case, we can declare a variable known as start or whatever variable we want, which will store the address of the first block, that is the first element in the list, which is 2 in this case. So here we have a pointer or a variable start which always points to the first element in the list. So now we can begin at start and move through the list by following the links in an easier way. So an example of such type of data structure that implements this concept is known as a linked list. Now here we come to the definition of a linked list and its various properties. So what is a linked list? A linked list is a dynamic data structure. Rather, it is also a linear data structure. We are calling it as a dynamic data structure because we are going to store elements. And when we are going to store elements, we deal with the memory. So as per the allocating scheme, a linked list is a dynamic data structure. It allows memory to be allocated as and when it is required. It consists of a chain of elements in which each of the element is referred to as a node. Now what is a node? Let us have a look. So a node is a building block of a linked list having the following structure. So here a node is basically having a two compartment. The first one which stores the information, the data, and the second one which stores the link or the address of its subsequent element. Here, all the nodes in a linked list are present at arbitrary memory locations. Means we do not have any sequence, any chronology for storing these elements. So these are the memory locations. For the first element it is 2403, for the second one it is 3352, for the third it is 5689, and for the last element it is 1012. So we can see here that we do not have any ordered allocation of memory. Therefore, every node in a linked list has a link field that stores the address of next node in the sequence. See. So the first one will store the address of second element, which is 3352. The second one will store 5689, which is the address of second element, and third element, and the third element will store the address of the fourth element. Now what about the fourth element, the last element? Since this list does not have any subsequent element, so it will be considered as the last element in the list, and its address field will point to null. That is, we do not know the address of subsequent element, or the list has ended over here. Now to keep track of the first node, we need to declare a variable or a pointer with any name. In this case, let us taking the variable with the name start, which will always point to the first node in the given list. So here, this start variable will indicate that the linked list is starting from this node. Now when the list is empty, start contains null. Start is equals to null. This means the linked list does not have any node. It is empty. Now here we have a problem for you, which we will discuss in the next session. So let us solve the given problem of storing prime numbers, which we had already discussed, using a linked list. So here we have the algorithm which implements a linked list. So repeat step number 2, varying n from 2 to 10 lakhs. If n is a prime number, then insert it into the linked list, and for insertion, allocate memory for the new node, store the prime number in the new node, and attach the new node in the linked list. After this, display the prime numbers stored in the linked list. So here we can solve this problem. We had already solved this problem using the array. Now we can solve this problem using linked list also. So in the next session we will discuss this problem in more detailed way, and we will come to know about the various operations that can be performed on a linked list. So dear students, thank you so much. We will come back again where we will discuss the various types of linked list as well as the different operations that can be performed on a linked list. Thank you so much.